Alright, this is Unit 2, Lesson 3, piecewise functions. Today, our goal for the day is to be able to graph a piecewise function, to be able to write the equation of a piecewise function if we have its graph, and to be able to evaluate a piecewise function using either its graph or its equation. So I want to start with just some functions that have domain restrictions. So f of x equals the square root of x plus 5 plus 2. So we have this root graph, but we have this little domain restriction right here. It's saying that that function is valid, or that function, we only want to keep the portion of it where x is less than 4. It's a root graph, but only part of a root graph when we graph it. So it's a function with a domain restriction. So when we're graphing this function, we know that it's this root shape, and its starting point is going to be at -5, +2, so that's here. And it doesn't have any stretches that would be in front of the root, remember, like if it was multiplied by 2 or something. This one's not stretched out, so it's going to be up 1 over 1, up 1 over 3, up 1 over 5 for this pattern that helps us graph it. So normally, if we were just graphing f of x without a domain restriction, we would sketch in this function like this, going off to the right. But what my domain restriction tells me is that we only want to keep part of that function, and the part of the function that we want to keep is the portion where x is less than 4. Well, here's the value 4 on my graph, the x value 4. We only want to keep the portion that is less than 4 and not including 4, so we would have an open circle here, and we would only keep this portion of the graph. Everything else we would want to erase, and that is not part of the function f of x because of that domain restriction. So it's a root, but it's only part of a root. Here's a function g of x. G of x is equal to 2/5 x minus 1, again with a domain restriction. So this is a line. You should recognize it as a line. It's in slope-intercept form. So -1 is the intercept, so it's going to cross the y-axis here, and the slope is 2/5 up 2 over 1, 2, 3, 4, 5. That's not going to fit anymore that way, but I can go back down to back 5. So it's this line. Sorry, that's kind of, slope's kind of funny over there. It's this line, but it's that line with a domain restriction. We only want to keep a portion of the line. The portion we want to keep is between -5 and 3. And it's okay that that's not at a real nice point there in between 0 and 1 in the y direction. And just keep that part in between. So here is the function g of x. Everything else, all these other two ends are extras, things that we don't need, so we would want to erase them. All right, so those are functions that have domain restrictions. They're pieces of functions. Well, today our topic is that we're talking about piecewise functions. Here's one. This is a piecewise function. This particular piecewise function has 3 pieces, and you can kind of see those pieces. Now, with the piecewise function, it could be the case, like right here, that the 2 pieces connect to each other, or it could be the case that there's a gap, a vertical gap between 2 pieces. So my function here is like a parabola shape, then it connects directly into a linear shape, then it jumps up and finishes out as a root shape. One function, 3 different pieces. So we're going to start today by trying to write the equation of this piecewise function. The equation of a piecewise function is somewhat complicated. It's going to look like this by the time we finish. So it's one function, so you see this f of x notation. We have one function, one equal sign, but the function is made up of many parts. Well, in this case, we have 1, 2, 3 parts. So we'll talk about what's going to go in each of those parts, but this is what our function will look like when we finish. So we're going to start by thinking about the equation of each piece. The equation of each piece is going to be in our piecewise function equation when we finish. So let's start with the parabola. Well, the parabola has a vertex right here at -5, -2. Remember, a parabola will have, let's see, sorry. Parabola will have this form with the power 2. So for our particular parabola here, and it's a good idea to maybe check and see if it's stretched, but this one is following a 1, 3, 5 pattern, so it's not stretched. So we'll use that vertex to write our equation, x plus 5 squared, and then minus 2, shifted down 2. Okay, so that's the equation of the part that is the shape of a parabola. Now we have a part that is the shape of a line. You get the matching color. Okay, so when you're writing the equation of a line, usually the easiest way to write it is in slope-intercept form. So you have the slope times x plus the y-intercept. Well, in this case, our y-intercept is 5. That's going to be the b value. And then the slope is that this is going down 1 over 1, down 1 over 1, down 1 over 1. So the slope is down 1 over 1. And if we simplify that, we really just need to keep the negative, or if you prefer, you can write it with the -1. So the equation of that second piece is a line with this equation. The last piece is a root. So this shape tells me that it's going to have the equation of a root, which is usually written something like this. So this particular root starts here at the point 1, 5, and it's a good idea again to check the pattern, but it looks like this one does not have a stretch. It's following the 1, 3, 5 sideways pattern. So if we're writing the equation of that piece, it would be x minus 1, so shifted forward 1, and then shifted up 5. Okay, so these three equations are going to be part of that piecewise function. Well, we also, in our piecewise function, need to specify which part of each of those equations or each of those functions that we are keeping. Which part of the parabola are we keeping? Which part of the line are we keeping? Which part of the root are we keeping? So let's think about first the parabola. It looks like the parabola, and we're thinking about which part of the domain. The parabola is covering the section of the domain between -7 and -2. Usually we'll write these in inequality notation for piecewise functions. That's the convention, is to use inequality notation. So we know that it's between -7 and -2. That -7 is definitely included. It has that filled in circle at the end. On the other end, it's a little bit ambiguous because it's connected. So you could kind of choose on this one if you wanted to include it on the -2 side or not. So you could potentially have that. I'm going to go ahead and include it on the line, so I'm going to leave it without, but it's not necessarily wrong if you chose to include it there. So now let's look at the domain of that second part, the line. So you can see that the line is covering the section of the domain between -2 and +1. Now I didn't include the -2 there, so I need to include it here. But on this other side, on the +1 side of that interval, we do not want to include that. It's got to be x is strictly less than 1. It can't include it on that side. And then finally, that last section The last section, the root, it's everything from 1 and larger. So we would say x is greater than or equal to 1. We do want to include 1 on that side because this point here is filled in. That's an included point on the root. So those are the domain restrictions for each piece. They tell us which part to keep of each of the different shapes. So this is what your equation ends up looking like. So again, one function, f of x equals, it's just the function f, but we have this brace that tells us it has 3 different parts. The first part here is the parabola between -7 and 2. The second part is the line between -2 and 1, and the third part has the shape of a root, and that's for x's that are greater than 1. So depending on what your function looks like, this one had 3 parts. Some functions only have 2 parts. Some functions have, potentially they could have more than 3 parts as well. So now I want to look at evaluating the function. First using the graph, and then we'll try using the equation. So for this function, f of -4, remember that when it's asking you f of -4, it is telling you the x value is -4, and it's asking you which y value the function takes on at that particular x value. So here's the x value -4. Well, my function has a value of -1 for that particular x value. F of 0. 0 is the x value here. Well, the height of the function at the x value 0 is 5. And then finally, f of 2. Well, 2 is here, so the y value that goes with that x value would be 6. So we've already practiced doing that. Hopefully that was a review for you. Using the equation to evaluate a piecewise function can be a little bit trickier. We're going to start with f of -2. Remember, this is an x value, and when we're evaluating a function using the equation, usually that means we just want to plug in -2 for x. Well, this function has lots of parts. You don't want to plug -2 into all of the parts. What you want to do is use the domain restrictions to figure out which part to use. So in this case, our x value is -2, and if I am looking up here at my different parts, -2 is not included here, but it is included right here. This is saying x has to be greater than or equal to -2. So -2 is in this one, in this group, or this interval. So this is where we want to plug it in. -2 plus 5. Well, -2 is +2 plus 5 gives me the x value 7. So if we look at the graph, now we were using the equation, but if we look at the graph, you can see that for the x value -2, the height is in fact 7. So evaluating the function this way works. Your job is to figure out which part of the function to use. So let's look at this one, f of 1. Well, 1 is definitely not in this interval. It's not between -2 and -7. It's not in this interval. This says x has to be less than 1, so it's not there. +1 falls into this group. It's greater than or equal to 1. So that means I'm going to use this equation, or this part of the equation, to evaluate it. The square root of 1 minus 1 plus 5. Well, the square root of 1 minus 1 is 0. Root of 0 is 0 plus 5 is 5. So f of 1 is 5. One more. We want to know what is f of -8. Well, -8 is definitely not between -7 and -2. It's not between -2 and +1, and it's not bigger than +1. So there's no part of the equation that we can plug this value -8 into, so we would say there's no answer, or you could say it does not exist, which some math people will just write D and E, but there isn't a way to get an answer for f of -8. It's outside the domain of the function. There is no solution to that question. All right, so let's try writing another equation. This one also has 3 parts. So let's start. So we'll do the first part on this first line. The first part of this function is a parabola. And usually when I'm writing the equation, I do work from the farthest left to the farthest right. So I'll start with this parabola. The vertex of this parabola is at -4, +3. Please note, I'm using the vertex. I'm not using this point. Sometimes people will try to use that end point of the piece, but you are, just like always when you write the equation of a parabola, you're using the vertex. So this is shifted back 4, so x plus 4, and shifted up 3. So here is the equation of the parabola, and it's not stretched, so that will be the equation there. Now I need to think about the domain of this parabola. Well, it looks like the domain is covering all values that are to the left of -3. They are less than -3. X is less than -3. And I'll double check to see if I should include it, but it's an open circle, so I should leave it just as is. Okay, the second section is a line. It's a horizontal line. So when you're thinking about lines, it's always mx plus b, usually. B is the y-intercept, so in this case, y, or that b value is going to be 2. But the slope is, this thing is going up 0 over 1, up 0 over 1. So this would be 0x plus 2. Well, that's just going to be the number 2. If you have a horizontal line, its equation is its y value. No matter which x value you pick, the y value is 2. So the interval for that particular equation, we're only going to keep a piece of that horizontal line, and the piece that we are going to keep is between -3 and +1. Always make those inequality symbols point towards the smaller value. For the endpoints, it looks like we are going to include that -3, but on the other side, that would be an open circle, so we don't want to include the 1. So our inequality, our domain restriction, will look like this. Finally, we have a line. Now normally, again, when we're writing a line, we use slope-intercept form, mx plus b. The slope I can count out pretty easily. It's going down 2 over 1, down 2 over 1, down 2 over 1. We would usually just write that as -2. The intercept is a little trickier because it's not crossing the y-axis currently as this piece. But what you have to do is just think about where it would cross the y-intercept or the y-axis if we weren't only keeping a piece of it. So it looks like this one would have or does have a y-intercept of 5. So the equation for that third piece is -2x plus 5. Now the part of that we want to keep, the domain restriction that we want for this last part, is that we want to keep everything that is larger than 1. X is greater than 1. And it's a solid circle filled in, so we do want to include it. So this would be the equation of that function. So now we want to evaluate it. F of -5, we'll use the graph if we can. If there's a value that's not on the graph, we will have to use the equation. F of -5 is on our graph. Here's the x value, -5. The y value that goes with that is 4. F of negative 5 is 4. The next one we want to look at is the x value 1. Well, the function at the x value negative 1 is a value 2, or a height of 2. The last one, f of 5. Shoot, this one doesn't show up on my graph, but it has an arrow here indicating that it does keep going over in that direction. So we can use our equation to evaluate it. Well, f of 5, well, 5 is over here, so you can see from the graph that it's going to be in that third part. But you could also look at the domain restriction here and see that 5 fits in this category of greater than 1. So that means we want to use this part of the equation, negative 2, plug in the 5, plus 5. Well, negative 2 times 5 is negative 10, and if we add 5 to that, we get negative 5. So f of 5 is negative 5. And you can kind of see that if we did project over one more unit, it looks like it would be down at negative 5. So that makes sense given the graph that we're looking at. Okay, if you want to try a super bonus challenge problem, and you should, go ahead and pause the video. This one has 4 parts. I will reveal the answer and you can check yours. Okay, so now let's work in the other direction. If you know the equation, can you sketch the graph? Well, again, you just graph each of those equations, but only keep the part that's indicated. So the first equation is a line. I know it's a line because it's in the form mx plus b. So it has an intercept of negative 1 and the slope of 1/3, up 1 over 3, up 1 over 3. Now, usually when I'm doing this, I don't immediately draw in a real heavy line here. I just put those dots to kind of show me where the line is going to go, and then I pause and think about which portion of the line I actually want to keep. Because I don't want the whole line, I only want part of the line. Well, this says that x has to be less than negative 3. Well, less than negative 3 means it's going to be over here with these numbers that are smaller than or less than negative 3. So the portion that we're going to keep is that far side. Starting here, that's the lowest, or sorry, the highest value we want, and then over here. Okay, so the domain restriction told me keep the portion of the line where the x values are less than negative 3. This will all get erased. So if you don't draw it super heavy at first, it will be a lot easier to erase the parts that you don't want to keep. The second part has the value of 4. That's still a line. It's like saying there's 0x plus 4. It's a horizontal line with a height or y value of 4. So it's up here. Again, I'd like to just sort of make a really faint line where it goes while I think about which part of it I want to keep. Well, in this case, we want to keep the part that's between negative 3 and positive 1. The negative 3 is included, so that's a solid circle. And then the other side, on the side where x is saying x is less than 1, you don't want to include the 1. So just everything in between those two values. Everything else is not part of this piecewise function. So we have this so far. We have one more part to go. We have a root. Okay, this is our root, this shape, and the starting point of this root is going to be 1, 1. Okay, so we're starting at 1. Up 1 over 1, up 1 over 3, up 1 over 5. So this is the shape our equation takes on. But we only want to keep everything in x greater than or equal to 1. Well, in this case, it does look like we get to keep the whole root. So that's kind of exciting. And that is included on that end there. So here's our function. Just graph So let me talk briefly about if you would just pause when you finish your graph and check it. So I'm going to change my graph so that it has an error in it so that you can see how to check. If I had, for a second, maybe made a mistake with this inequality and I had kept this side of the line, if I'll just pause when I finish my graph and do a quick vertical line check, and right here I can see, shoot, this is not okay. I must have made an error because you can see these two functions are, or these two parts are right on top of each other. It's not passing the vertical line test for functions. So I know that I've made an error immediately. So then it'll give you a chance, if you'll check, to just go back and think about which one of those domain restrictions you might have made an error on. And in this case, we should have kept this side and not the other side. So a vertical line check, when you finish graphing a function, can help you catch those errors. Let's try one more. This one just has two parts. So the first part is a cube root shape. That would be this. This particular cube root starts at the point 0, -2, so down here. It's a 1, 7 pattern for cube roots. So I'm just going to kind of dot it at first until I decide which part to keep. So there's where the cube root is located. We want to keep the portion that is less than or equal to 1. That would be starting here. So solid circle here, and the part I'm keeping is this part over here. Everything else that's greater than 1, x value greater than 1, I'm going to erase. Okay, the second part of this is a line. 5 is the y-intercept. So here, -2 is the slope, so the slope is going down 2 over 1, down 2 over 1, 2 over 1, and dot that in, so you can see where it's located, and then think about which part you want to keep. You only want to keep the part between the x value 1 and the x value 5. So just this part of the line, and anything else we want to erase. So here's our function. Alright, here's Super Bonus Challenge problem. Pause the video if you want to try it, which you should, because if you do it, it's awesome. And so pause the video if you want to do it, and here is the solution. Alright, just the last two graphs here quickly. I wanted to just show you that the way that your function ends up looking depends a lot on that domain. So these two equations, I should call one of these something else. Let's call this one G. These two equations are very similar. They both have part of an absolute value and part of a line, and it's the same absolute value and inline that they have a part of. The only difference is that the domain restriction here is changing at the x value 0, and here the restrictions, or the part that we're using is changing at 2. So let's graph these two so you can see how they look kind of similar but kind of different. So this absolute value is a V shape at the value, vertex is at the value -3, -2, so here it is. And again, I'm just going to dot it in at first until I can decide what I want to keep. Our domain restriction here says we want to keep the portion where x is less than or equal to 0. This is the x value 0, so we want to keep this part of it. The other part of this graph is a line with a y-intercept of 1, so the y-intercept is here, and the slope is it's a negative x, that's -1, down 1 over 1, down 1 over 1. So it's this line. Here, let me look like a little circle that I was thinking of. line we want to keep, only a part of that, the portion that we do want to keep is the part that is greater than 0. So that would be this part over here. Everything else we would want to erase. And so our function looks like this. It looks like Harry Potter's lightning spell. G of x, again, has that same absolute value, that same line. So we know we have a vertex here. But this time our domain restriction is that we want to keep the portion that is less than or equal to -2. So it's going to have a built-in circle here. And we'll just be taking this portion of it. The line again is the same line. It has a y-intercept of 1 and a slope of -1. But we want this time the domain restriction is that we want to keep everything greater than -2, so we would put an open circle here and keep this portion. Everything else up here we want to erase. So they definitely have some similarities